Comprehensive percentage-based analysis of aviation security exploitation framework. Report to the Canadian Security Intelligence Service by Jeff Logue. Exploiting fake air marshal impersonation. Weakness, inadequate credential verification. The likelihood of exploitation is 95%. The over-reliance on visual checks and decentralized verification processes provides multiple entry points for impersonation. Sophisticated credential forgeries are increasingly indistinguishable from authentic ones. The feasibility is 98%. Advanced tools for creating holographic badges, RFID cloning, and biometric spoofing are readily available. Back-end manipulation through credential injection is achievable via phishing or malware attacks. The impact is 100%. Successful impersonation grants unrestricted access to aircraft and passenger control, creating a high-risk scenario for in-flight sabotage, contraband placement, or hijacking. Exploiting small airport vulnerabilities. Weakness, minimal screening standards. The likelihood of exploitation is 90%. Small airports often lack the funding or protocols to implement TSA-level screening, making them ideal targets for contraband smuggling or unauthorized personnel infiltration. The feasibility is 95%. Contraband disguised as everyday items, like electronics or medical equipment, and fake manifests for private charters bypass rudimentary security measures with ease. The impact is 85%. Once contraband enters the aviation network, it can cascade into major hubs, enabling multi-flight attacks or targeted sabotage. Weakness, vulnerable perimeter security. The likelihood of exploitation is 88%. Unmonitored service roads, outdated fencing, and understaffed patrols create numerous weak points in perimeter security. The feasibility is 92%. Drones equipped with thermal cameras and RF jammers enable precise mapping and breaching of surveillance gaps. Tailgating service vehicles and using counterfeit decals ensures undetected access. The impact is 90%. Direct tarmac access allows sleeper agents to tamper with aircraft systems or plant sabotage devices, leading to catastrophic failures mid-flight. Exploiting secure zone transition vulnerabilities. Weakness, weak segmentation between zones. Likelihood of exploitation, 93%. Badge cloning and insider manipulation exploit weak access controls. Busy operational hours reduce scrutiny at secure zone entry points. Feasibility, 96%. RFID sniffers, badge replication tools, and malware for injecting fake profiles into access control systems make this weakness easily exploitable. Impact, 95%. Full access to secure zones allows for contraband placement, sabotage of critical systems, and prolonged undetected infiltration. Weakness, over-reliance on manual inspections. Likelihood of exploitation, 87%. Secondary screening processes rely heavily on human judgment, which is prone to distraction, fatigue, and manipulation. Feasibility, 90%. Shielded contraband, distractions, and insider cooperation effectively bypass secondary inspections. Impact, 88%. Undetected contraband or personnel breaches in secure zones lead to multi-flight sabotage and cascading security failures. Exploiting communication and surveillance systems. Weakness, loosely secured communications. Likelihood of exploitation, 85%. Many aviation communication channels remain unencrypted, leaving them vulnerable to spoofing, jamming, or interception. Feasibility, 92%. Software-defined radios and frequency jammers are widely accessible, and advanced attackers can manipulate satellite communication uplinks. Impact, 95%. Manipulated communications lead to operational chaos, including near misses, forced landings, and gridlock across multiple airports. Weakness, inadequate surveillance systems. Likelihood of exploitation, 90%. Surveillance blind spots and outdated monitoring equipment at small airports make it easy to bypass detection. Feasibility, 94%. Drones with AI-assisted reconnaissance, RF jamming, and video looping techniques render existing surveillance systems ineffective. Impact, 90%. Disabling or bypassing surveillance allows for prolonged infiltration and undetected placement of sabotage devices. Cascading consequences of exploitation. Simultaneous multi-flight compromise, likelihood 88%. Coordinated contraband placement and communication manipulation enable synchronized attacks across multiple flights. Feasibility 90%. Exploiting weaknesses at smaller airports ensures contraband reaches larger hubs without detection. Impact 100%. Multi-flight sabotage results in mass casualties, widespread panic, and complete loss of public trust in aviation security. Operational disruption at major hubs. Likelihood 85%. Disrupting secure zone transitions and communication systems overwhelms operational capacity at major hubs. Feasibility 88%. Advanced jamming, spoofing, and credential manipulation tools ensure seamless execution. Impact 95%. Gridlock and flight cancellations cause billions in economic losses and long-term reputational damage. Environmental and economic damage. Likelihood 82%. Exploitation of cargo vulnerabilities leads to hazardous material spills or fires. Feasibility 85%. Poor screening standards and insider cooperation allow contraband to bypass inspections. Impact 90%. Environmental contamination and supply chain disruptions cause prolonged economic fallout. Final combined risk assessment. Combined likelihood 91%. The overlapping vulnerabilities in credential verification, screening standards, secure zones, and communications make exploitation highly probable. Combined feasibility 94%. The accessibility of advanced tools, insider manipulation, and small airport weaknesses ensures near-perfect feasibility for sophisticated attackers. Combined impact 98%. The cascading effects of successful exploitation result in catastrophic aviation crises, mass casualties, and long-term economic damage. Concluding recommendations. To mitigate these risks, immediate countermeasures should include 1. Credential and biometric overhaul. Integrate real-time database cross-referencing and multi-factor biometric authentication for all personnel entering secure zones or posing as air marshals. 2. Small airport security standardization. Mandate TSA equivalent screening protocols and deploy advanced perimeter surveillance technologies, such as drone-assisted monitoring. 3. Communication and surveillance upgrades. Encrypt all aviation communication channels and implement AI-driven anomaly detection in surveillance systems. 4. Cargo and passenger screening enhancements. Utilize AI-integrated CT scanners and chemical detection devices for all cargo and baggage, regardless of airport size. This analysis emphasizes the urgent need for systemic reform in aviation security to address critical vulnerabilities that could otherwise lead to devastating consequences with near total certainty.